Hello, ladies and gentlemen. If you're getting to this video, then you already went to the Google Classroom, you found it, good job, you're doing the right thing. To do the problems assigned today, you're going to need some background information called a lesson. So the first thing that you have to know is that we're going to try to use a sequence to find the next term. And when we find the next term, we're going to be doing something like this. We're going to be thinking recursively. We're going to find a recursive formula and then maybe use it. So what you need to know is that there's a formula in algebra called the recursive formula. It helps you find the next term. So here it is. A sub n equals a sub n minus 1 plus d. This is our unknown, and it's already isolated on this side. It's always going to be our unknown. This is the last term given in the sequence. And this, ladies and gentlemen, is the common difference. So in order to explain this, I'm going to give you an example. Here's example number 1. This is a sequence of numbers, 81 first, then 85, then 89, on to 93, 97, and this sequence would continue on because there is a pattern. Here's how you find the pattern, and here's how you prove that it's an arithmetic pattern. You prove it's arithmetic by taking the last term that you have and subtracting the one before it, and then taking that term and subtracting the one before it, like this. And you keep doing that. 89 minus 85 and 85 minus 81. If all of these are the same answer, then this is an arithmetic pattern because there will be a common difference. So this is 4, this is 4, this is 4, and this is 4. All of these outcomes are the same. That means we have just found the common difference, D. It's 4. So now that we have the common difference, we can write what's called a recursive formula. And that is the next term is equal to the last term, a sub n minus 1, in this case, plus 4. This is the recursive formula for the given sequence, 81, 85, 89, 93, 97. So there's the formula. Now, how do you use it? Here's how you use it. If I want to find the next term, which is what a recursive formula does, then I'm going to say that I want a sub 1, 2, 3, 4, 5, 6. I want the 6th term. That's the next term I want. The previous term was 97 plus the common difference of 4. So I just found the next term, the 6th term, it's 101. Now, there's another type of thought, and this other type of thought is more powerful. It's called thinking explicitly. When we have sequences, we're going to have an explicit formula. And the explicit formula finds, and I want you to write this in all caps, any term, even the next one. So the explicit formula is very powerful, but there's certain things you need to make it work. Here's the formula. A sub n equals a sub 1 plus n minus 1 times d. As a matter of fact, we were using this yesterday in class. This is the explicit formula, and it'll help you find any term. So remember from yesterday that a sub n is our unknown. And when we're done using the formula, we're going to find out what the unknown is equal to. A sub 1 is the first term. N is the term number, and we already know D is the common difference. So how do these get used? What do we do? We can find the explicit formula for that same sequence right up there. Here's how. If any term can be found, if we know the first term, we do. It's 81. Remember, right up here, 81 was the first term. I replace a sub 1 with 81 plus n minus 1 times the common difference, d, and we already know that because we found it right up here. Recursively, we found the common difference. So if you want to actually write the formula explicitly, you could stop there, but you shouldn't, because we have algebra skills. We know that an expression must be simplified fully. So 81, and we're going to do what's called back distributing. 4 times n is 4n. 4 times -1 is -4. And you guys should know that you should simplify as much as possible. 81 minus 4 is 77. So that'd be 77 plus 4n. And now I'm going to switch this order, and it's going to look like a linear function. A sub n is equal to 4n plus 77. So this formula can help us find any term. As a matter of fact, I'm going to create an example that makes us use this formula for this sequence right up here. And I'm going to call that example number 2. For example number 2, I want to find the 27th term. Remember when I said any? I mean any, 27th. I could be the 127th, the millionth, it doesn't matter. I'm going to find the 27th term using the explicit formula I just created. The formula I created was a sub n equals 4 times n plus 77. So all I need to do now is know that I want the 27th term. That's what goes here for n. That's what goes here for n. So a sub 27 equals 4 times 27 plus 77. A sub 27 equals 27 times 4 plus 77. If you use your Desmos calculator, you're going to get 185. So I use the explicit formula that I found just previously to find the 27th term, and it'll work for any term. Okay, now let's do a few problems so you can figure out what to do for the assignment I gave. Number 17 is from the assignment I gave. It says, figure out if the sequence is arithmetic. Here's the sequence for number 17. 1, 15, 29, 43, and 57. How do you figure out if it's arithmetic? You find out, is there a common difference? How do you find out if there's a common difference? You start subtracting the last term you have minus the previous term. The previous term minus its previous term, and so on, and all the way down till you get to all the terms in my subtraction. If all of these outcomes are the same, I've found a common difference. If I found a common difference, that means that this is an arithmetic sequence. There's a pattern of addition. 57 minus 13 is 14. 43 minus 29, also 14. 14, they're all 14, which means I just found a common difference. D, it's 14. Once I find the common difference, then that proves that this sequence is arithmetic. Whoops, sorry about the messed up spelling. Let me try that again. Arithmetic. Bad spelling. Okay, let's keep working. The next section is number 25, and we have a sequence. It's 12, 19, 26, 33, and 40. The question is, can you write both a recursive and an explicit formula? So we should be able to do that now that I gave you the notes. If you want to write the recursive formula, all I need is the common difference. Now I can go through this and find the common difference, or I can do that much simpler by saying what plus 12 is 19 plus 7. What should I do to 19 to get 26? Add 7. If it's add 7 every time, then I found a pattern. That's called the common difference. 7 plus 26, yep, it's 33. 33 plus 7 again, yep, it's 40. So guys, I just found the common difference D, it's 7. I can now go straight to the recursive formula, which I already have in my notes. It's sitting right over here, and use it. The next term is equal to the one previous to that, plus 7. This is one of the answers for number 25. It's the recursive answer. Now on to the explicit answer. For the explicit answer, I'm going to use this formula right over here, right next to it. Any term can be found if we take the first term and add n minus 1 times d. So how do we do this? We take our 7, which we know is d, and put it right there. We take our first term, which we know is 12, and put it right there. and we write down any term is equal to 12 in this sequence, the first term, plus n minus 1 times the common difference of 7. But we have to simplify so we have the correct answer. A sub n is equal to 12 plus 7n minus 7. 12 minus 7 is 5. So we're going to switch the order, and 7n minus 5. Not only is it linear, but it's the explicit formula for number 25. There's the answer for the explicit. There's the answer for the recursive. Let's do one more, maybe two more. Let's do two more problems because there's two more sets of problems to do. The next set starts with number 31. Oh, by the way, skip 29 and 30. That's confusing to me as well. So let's go to 31. Number 31 gives us a recursive formula. It says a sub n equals a sub n minus 1 plus 15. From that, I know the common difference. The common difference is 15. On number 31, it also tells us the first term. And that, ladies and gentlemen, will help us write the explicit formula. The explicit formula then is a sub n equals the first term plus n minus 1 times the common difference. And now again, you've got to use your algebra skills and simplify as much as you can. That's 8 plus 15n minus 15. Algebra skills come in handy on problems like this as well. Negative 15 and 8 gives us negative 7, so my answer would be 15n minus 7. I added like terms. There's the answer for number 31. And now let's finish up with number 37. So number 37 gives us an explicit formula. Now, even though these aren't in the order I would put them, let's put them in the order I would write them, 8n plus 10. Still, there's something hidden in both of these forms that we should understand. Remember, when we were given the recursive formula and wrote the explicit, we had to distribute the 15. And 15 times n was 15n, which means that this was the common difference. And now this is the common difference still. It was our counting number times n. So guys, the number in front of the letter n, to the left of n, that's d. D is 8. Even in this form, d has to be 8. So now that I know that, I can write my recursive formula. Because for the recursive formula, all you need is d, 8. So you can write a sub n equals a sub n minus 1 plus or minus, depending on the sign, a common difference. This is the answer for number 37. Thanks for watching, and thanks for doing a great job today.